In this question, we're going to do a periodic function word problem question involving tides. Imagine that the tides at Massey Beach come in and go out 3 times per day. Okay, right away when we say here that they go in and out 3 times per day, what we're saying is that the period is equal to 24 hours, which is 1 day, divided by 3. So we can tell right away the period's going to be 8 hours. Now, the maximum height of the tides is 56 meters and the minimum height is 22 meters. And the first time during the day the maximum height occurs is at 1:10 a.m. So we're going to determine a formula representing the height of the tide at any time in minutes, determine the height at 5:30 p.m., and also figure out what times during the day the height's equal to 28 meters. All right, well, we know that 1:10 a.m. occurs 70 minutes into the day. How do we know that? Well, that 1 right there represents 1 hour, which is 60 minutes. And then that 10 right there represents another 10 minutes. So 1:10 a.m. is actually 70 minutes after midnight when the day starts. Now, that's going to be our phase shift. So we can kind of tell right away our phase shift is going to be 70. Now, since the tides come in and go out 3 times per day, as mentioned earlier, the period is 8 hours. That means the second maximum is going to occur at 9:10 a.m. because 8 hours after 1:10 a.m. is 9:10 a.m. Well, 9:10 a.m. is 550 minutes after midnight. How do we know that? Because 9:10 a.m. means that 9 hours have gone by, which is 540 minutes plus another 10 minutes. So the second maximum occurs at a time of 550 minutes. Okay, so we can see we're able to draw one cycle of the curve like this. We go from the maximum down to the minimum, back up to the maximum again at 1:10 a.m. and at 9:10 a.m. we're at the maximums. All right, good stuff. Now let's come up with a formula for this. And obviously we know that the tides are going to continue to go in and out all day and go into the next day, et cetera, et cetera, et cetera. Well, what's our amplitude here? Well, you might be able to tell just by looking that the amplitude is 17, but if you can't tell just by looking, then what you can do is use the formula of maximum y value minus minimum y value over 2. If you do that, you see that the amplitude is equal to 17. The c value is maximum y value plus minimum y value over 2, so that'll be a 39. So we know our amplitude, we know our axis of symmetry, and we have a phase shift for d. We're using positive cos as our parent function. Now, since the period is 8 hours, we'll call that 480 minutes. Since 480 is a rational number, we'll put our calculators in degree mode, and we'll say that k is equal to 360 over the period. Well, 360 over 480 is 3/4. So we end up with a function for our curve being that h of t is equal to 17 cos 3/4. This should say t minus 70 plus 39. Okay, awesome. There we go. We've got that written down. Now, how about that answers part A? How about part B when it says to determine the height of the tide at 5:30 p.m.? Well, what we want to do is figure out how many minutes after midnight 5:30 p.m. is. Well, 5:30 p.m. means that we're into the p.m., which means we've already gone by 12 hours. Plus, since it's 5:30 p.m., we've gone by an additional 5 hours, plus we've gone by 30 minutes to get to 5:30. So this is a total of 17 hours plus 30 minutes. Okay, so 17 hours is 17 times 60 minutes. Also add that 30 minutes, and we're at 1,050 minutes after midnight. So that's going to be our t value. We plug in 1,050 for t, make sure our calculator's in degree mode, do our calculations, and we get 55.4. So we can say the height of the tide at 5:30 p.m. will be approximately 55.4 meters. Now finally, what if we want to know what times during the day the height is equal to 28 meters? All right, well, the height is measured on the y-axis. So basically, we're saying that our height is 28, which would be right about here. And we're curious what these times are right here. Okay, and we're curious about them not just on the first cycle, but all through the day. Well, what we do is we let h of t equal 28. We subtract 39 from both sides, and we get negative 11 equaling 17 cos 3/4 t minus 70. We divide both sides by 17, and we see that there's an infinite number of solutions to negative 11 over 17 equaling cos of something. Now, keep in mind that the angle in the question is whatever we're operating the trig function on. So in this case, the cos is operating on 3/4 t minus 70. So what we can do, if it helps us to think about it, is we can say theta equals 3/4 t minus 70. Theta is the angle. And then just say that negative 11 over 17 equals cos of that. In other words, negative 11 over 17 equals cos theta. Now let's find the domains to that in the, let's find the solutions to negative 11 over 17 equals cos theta in the domain 0 to 360 and go from there. Well, letting cos be negative 11 over 17 means we're going to have a couple of terminal arms out here. Using our calculator to determine the cos inverse of negative 11 over 17, we get 144.8. Our second angle in the first cycle around from 0 to 360 will be 215.2. So what that means is that theta 1 is going to equal roughly 144.8, and theta 2 is going to equal roughly 215.2. But what does theta equal? Well, you might recall a couple slides ago, we said theta is equal to 3/4 t minus 70. So we can say, if we're talking about theta 1, we can say 3/4 t1 minus 70 is roughly equal to 144.8. And similarly, say 3/4 of t2 minus 70 is roughly equal to 215.2. Well, if we take this equation right here and solve it, the first thing we do is divide each side by 3/4, and we get 193.1 on the right-hand side. And then we add 70 to both sides, and we get 263.1. So T1 is roughly equal to 263.1. Okay, and that's what we show in this diagram. Our height is 28 meters, and it's hitting for the first time at a time of roughly 263.1 minutes. Okay, well, T2 will be, if you recall earlier, we said theta 2 is 215.2 degrees. So since theta is equal to 3/4 T2, T minus 70, we can say 3/4 of T2 minus 70 is roughly 215.2 degrees. Dividing both sides by 3/4 gives us 286.9 on the right-hand side. Adding 70 to both sides tells us that T2 is roughly equal to 356.9. Okay, so we know the first two times that way. But we want to state them as times on a clock because that's how the question is worded. So we want to figure out what time is 263.1 minutes after midnight. Well, 263.1 minutes after midnight is 4 full hours, because 4 full hours is 240 minutes, plus an additional 23.1 minutes. So it's 4 full hours plus 23 minutes after midnight. What do we call that? We call it 4:23 a.m. And similarly, 356.9, that's equal to 5 full hours after midnight, plus an additional 56.9 minutes. So that's actually equal to 5:57 a.m., roughly. Okay, so we want to be able to figure those out. So we're basically hitting at 4:23 and 5:57 a.m., the height in question. Now, because this cycle will repeat perfectly, we're going to end up right here exactly 8 hours after 4:23. And we're going to end up right here exactly 8 hours after 5:57. And so what time is 8 hours after 4:23 a.m.? The answer is 12:23 p.m. And then it's going to repeat perfectly again one more time. So right here, from right here to right here is going to be exactly 8 hours because we're at the same point in the cycle heading down. And similarly, from this point right here to this point right here is going to be exactly equal to 8 hours because we're at the same point in the cycle heading up. So we see that at this point right here is 4:23 a.m. At this point right here, exactly 8 hours later, we'll be at 12:23 p.m. And at this point right here, exactly 8 hours later, we will be at 8:23 p.m. Okay, but also we want to know about the other times. We want to know, we know this time is 5:57. We want to know 8 hours later what that time is, and we also want to know 8 hours later what that time is. Well, 8 hours after 5:57 a.m. is 1:57 p.m., and 8 hours after 1:57 p.m. is 9:57 p.m. Okay? So we're able to say exactly when our 6 times are. If we let this go through 2 more times to give us a full day, we'll see that at 4:23 a.m., which is right here, we're at the time in question. At 5:57 a.m., which is right here, we're at the height in question. At 12:23, which is right here, we're at the height in question. At 1:57, which is right here, we're at the height in question. At 8:23, which is here, we're at the height in question. And finally at 9:57, which is right here, we're at the height in question. Now, that's our final answer to this question. Had the question said something like, when is the, for how long during each day is the tide below a height of 28 meters, then all we would really have to do is figure out how much time there is in between 4:23 and 5:57. And to figure that out, we could go back a while ago to when we knew when we had 4:23 written as approximately 263.1, and we could go back to when we had 5:57 written as approximately 356.9. And to determine how many minutes there are in between these two, we would just have to subtract. And if we do that, we end up with, as I do this in my head, we have 90, so we're missing here, 3.1, 93.8 minutes. So there are 93.8 minutes in between here. Okay? And then all we would have to do is multiply that by 3 because we know that it repeats itself 3 times per day. And that 93.8 times 3 would give us a total number of minutes that would represent the length of time during a day that we are below a height of 28 meters.